Just think about the last thing you bought online or the weather forecast you checked this morning. Heck, even the show you just streamed. Every single one of those clicks, those little actions, they all generated data. We are absolutely swimming in a sea of information, a constant, chaotic flood. So how on earth do we turn all that noise into something that actually makes sense? And this, right here, is what it looks like in its raw form. Just a tangled mess of puzzle pieces with no clear connections. It's overwhelming, mostly because it has no structure. So the big question we're tackling today is, how do we build a plan to find the answers that are hiding inside all of this chaos?
Well, the solution is a process called data science. And please, don't let that name intimidate you. The best way to think about it is like a recipe. You take a bunch of raw ingredients, that's your data, and you follow a set of structured steps to create something meaningful. That's your insight. It really is all about turning chaos into clarity. To guide us through this, we're going to be using this fantastic playbook. It was developed by India's Central Board of Secondary Education, or CBSE, and they did it in partnership with Microsoft. We're going to dive into its core principles to really build our understanding of data from the ground up. Okay, so where do we even start with that tangled mess of data we saw a second ago? Well, the very first step is to tame the beast. And this is all about taking that raw, chaotic information and just sorting it. Sorting it into something manageable so we can go from a jumble of facts to clear, organized categories. A really important technique for taming data is creating what's called a subset. Think of it like this. If you have a massive library of books, you wouldn't read every single one to find information on one specific topic, right? Of course not. You'd go to the relevant section. A subset is just like that relevant section. It's a smaller, more focused piece of the data that helps you zoom in on what actually matters for the question you're asking. Let's make this real. Imagine you're looking at raw survey data about what movies people like. It's just a list. 8 men like comedy, 12 men like action, 16 women like comedy, 6 women like horror. Can you quickly tell which genre is the most popular overall, or how preferences differ between men and women? It's tough, because it's just a wall of text. But watch what happens when we organize that exact same data into a simple table. I mean, boom. Suddenly the patterns are impossible to miss. We can instantly see that comedy and action are tied for the most popular, and that women really prefer comedy, while men lean more towards horror and action. The data itself didn't change at all, just the way it's structured. And that structure is what unlocks the insights. All right, so now that our data is all neat and organized, we can start to figure out what it's actually telling us. The first step there is to find its center, to figure out what a typical value looks like in our data set. You can almost think of it as finding the main character in our data story. Now, the most familiar way to find the center is by calculating the mean, which I'm sure you know better as the average. It's a simple idea, but it's really powerful. You just add up all your values and then divide by how many values you have. And it gives you one single number to represent the whole group. But the mean isn't the only tool in the shed. We also have the median, which is simply the middle value when you line up all your data in order from smallest to largest. And this creates a really critical choice for anyone working with data. When is the average the right tool for the job, and when is that middle value a better representation of the truth? This example of a faulty blood pressure reading from the handbook makes it so clear. That one bad reading, we call that an outlier, it can pull the average way, way off course. But the median, the true middle value, it's not affected by that one crazy number. It stays stable, giving a much more accurate picture of the person's typical blood pressure. So the key takeaway here is, when your data has extreme values, the median is often your most reliable guide. So we've found the center of our data. But that's really only half the story. Just knowing the typical value isn't enough. We also need to understand how spread out or clustered together the rest of our data is around that center. It tells us about the consistency, the predictability of our data. Okay, get this. What if I told you 2 cities have roughly the same average annual temperature? Does that mean their weather feels the same? Not even close. Think about San Francisco and St. Louis. Their averages are similar, but San Francisco has mild, consistent weather all year long, while St. Louis has scorching summers and freezing winters. The average tells you the center, but it completely hides the story of the extremes. To capture that story of the extremes, we use a tool called standard deviation.
It's really just a single number that tells you how spread out your data is from the average. A low number, kind of like San Francisco's weather, means the data is all tightly clustered and consistent. A high number, like St. Louis's weather, means the data is all over the place. So look at these two. They could have the exact same average, but their stories are worlds apart. The data set on the left is consistent, it's predictable, you pretty much know what to expect. The one on the right, though, it's volatile, it's unpredictable, and understanding the spread is absolutely crucial for everything from financial investing to medical diagnoses. And this is not just some abstract math concept, okay? This is a really practical tool. How do you know if a new teaching method is working for all students or just a few? You look at the standard deviation of their test scores. How do you know if you can trust a weather forecast? A low standard deviation tells you that forecast is way more likely to be accurate. It's a measure of consistency and trust. So, we've gone on this journey from total chaos to crystal clarity. We've learned how to organize data, how to pull powerful insights out of it. But that power, it brings with it a profound responsibility. The final, and you could argue the most important step in this whole process, is ethics. Because you see, the process doesn't just end with a chart or a statistic. It ends with a decision, and that decision can impact people's lives. The goal isn't just to find the right answer, it's to use that answer in the right way. It's not just about being correct, it's about doing good. You know, the fact that the CBSE and Microsoft Handbook dedicates an entire section to ethics, that speaks volumes. This isn't some footnote or an afterthought. It's treated as a foundational pillar of data science. It sends a really clear message. Yeah, understanding the math is important, but understanding the human impact is absolutely essential. So our journey has taken us from chaotic data all the way to clear insights. But this is where the real work begins. As data continues to shape our world in really profound ways, from the ads we see to the loans we get, the most important question isn't about means on medians. It's about morality. What is the one ethical line that we as a society should decide we will never cross?